Hi everyone, I'm back. For this video, we will have the graph of the sine function or the sine function itself. So we will have the domain, range, and the amplitude and period of the sine function. So to better understand the terms that I have mentioned, please stay in this video and watch it. Okay, so we will have here the sine function. So consider the function y equals sine x. So in this function, if you can still remember that the sine of an angle, let's say for example, this x is an angle, is the y coordinate of the terminal point on the unit circle. Okay, so the sine of an angle is the y coordinate or the y. So sine is y in the unit circle. So for example, here, the sine of 0 is 0. So the y coordinates. So we will be having the y coordinates here for the values of the sine of the angle. Okay, so in order for us to graph and observe the behavior of this function, we need to graph it first. So for us to graph, we need to give values of x and then solve for the y value corresponding to the x. So if x is 0, the sine of 0 is the y coordinate here. If the angle is 0, so that is 0. So we have a point here, 0, 0 on the graph. So 0, 0 is here. Okay, 0, 0. What about if x is pi over 4? So as what you can see here, the values that I chose for x are only multiples of pi over 4 so that we will not have a lot of values. So with these values, hopefully, we can already look into the graph, or we can connect them to make a smooth curve. Okay, so if x is pi over 4, we will have sine of pi over 4. And pi over 4 is here, and the y coordinate there is square root of 2 over 2. So square root of pi over 4, square root of 2 over 2. So pi over 4, square root of 2 over 2 is approximately 0.7. So it's here. And then if x is pi over 2, sine of pi over 2. So pi over 2 is here, so that is 1. So 1. So when x is pi over 2, y is 1. So we have pi over 2, 1, so it's here. And then if x is 3 pi over 4, here, we have square root of 2 over 2, still 0.7. So it's here. And then when x is pi, we have the sine of pi is 0. So pi 0 is the point here. And then if you will have 5 pi over 4, that's negative 0.7. So 5 pi over 4, negative 0.7 is here. And then when it's 3 pi over 2, sine of 3 pi over 2, that's negative 1. Here, this is negative 1, the y coordinate. And then when x is 7 pi over 4, the angle is 7 pi over 4, we have negative 0.7. So if x is 7 pi over 4, negative 0.7 is here. And then when x is 2 pi, the sine of 2 pi is 0. So 2 pi 0 is in this point. And then if you will add more values of x here, the graph will just repeat. It will be like this. So if we connect the points, it will be like this. So the sine function looks like this, the graph. Okay, so if you will add more values of x, it will just repeat Okay, it will repeat and then it will again repeat. So what is the domain of this function? Y equals sine x. So this is sine of x, and this one is a measure of an angle. And as what we have discussed last time with the unit circle, an angle can be any number, positive or negative, or it can also be zero. So the angle can be any real number. So for the domain of this function, we can get the sine of any real number. So the domain or the x values can be any real number. So this is how we write the set of real numbers in interval notation. That's from negative infinity to positive infinity. Or simply R, the set of all real numbers. So we write that as R, the set of all real numbers. How about the range? If you look at the Y values here for the range, the maximum value is 1. It will not go higher than 1. And then the lowest value is just negative 1. It cannot go lower than negative 1. So the lowest value for y is negative 1, and the highest value is positive 1. And there are also values in between. Okay? So the range of this function is the closed interval from negative 1 to 1. Okay, so it can be any number from negative 1 to positive 1. And then we have the period. Since, as what I have said just a while ago, this function or this, what they call this cycle will repeat. From 2 pi, it will again make something like that shape also. So we call these functions periodic functions, meaning to say after a certain interval, it will repeat itself. It will repeat. So it will be like this again here, here. So that is from x equals 0 to x equals 2 pi. That is one cycle of the graph. And then from 2 pi, it will make another like that until 4 pi. So this is a periodic function. And the period is the length in the x values until such time it will repeat itself. So we have 2 pi. So from 0 to 2 pi, that is 2 pi. Okay? And another from 2 pi to 4 pi, it will have another cycle. So the period is 2 pi. So every 2 pi units, the graph will repeat itself as you move to the left or to the right. And then we have the amplitude, another term. So the amplitude here is 1. In the function y equals a sine x, the absolute value of a is the amplitude. The absolute value of the number here before sine x is the amplitude. It dictates the height of the curve. So the height of the curve is like this, from 0 to 1, so that's 1 unit. So the amplitude here is 1, okay? So the function here is y equals sine x, and there is no number here before sine. That means to say that it's 1 there. So the absolute value of 1 is 1. Therefore, the amplitude of y equals sine x is 1. So when that value there, when the absolute value of the number before this sine x is less than 1, the graph is shrunk vertically. Okay, it's like shrunk vertically, shrunk. And then if a, or the absolute value of the number before the sign, is greater than 1, the graph is stretched vertically. Okay, so it becomes taller, the graph. Here, the graph becomes shorter. Okay, so recall the graph of y equals sine x. So it's like this, from 0, x equals 0 to x equals 2 pi. That's one cycle of the graph. and then it will just repeat here to the left and to the right. Okay, how about if we have y equals 2 sine x? What do you think will, how will the graph look like? So as what you can see, the sine x is just multiplied by 2. Therefore, all the y values will be multiplied by 2. So if we multiply 2 to all those values that we obtained a while ago, we will form a graph that looks like this blue graph. Okay? So instead of 1, the highest now is 2 because it's times 2. The lowest now is negative 2. Okay? So when x is 0, y is still 0. When x is pi, y is still 0. And when x is 2 pi, y is also 0. So it will have a change here. The highest value is 2 and the lowest value is negative 1. So this is stretched vertically since 2 is greater than 1. So it's stretched vertically. So as what you can see, the graph looks taller here. Okay? The highest point is here and the lowest point is here. But of course, if you will have another cycle for this, there's another highest point here, or the relative maximum point here and relative minimum point. Okay, how about if the function is y equals 3 sine x? So how will the graph look like? So it's just going to be like this. Okay, much taller than y equals sine x. So maximum point here is at 3, and then minimum value is negative 3. Okay, so that's the effect when we change the number here before the sine x. If we have values greater than 1, it will stretch the graph vertically. How about if we have a value before sine x that is less than 1? What effect will it make on this y equals sine x in the red one? So it's just going to be this. It's a shorter graph. Maximum value is at 1/2. Minimum value is negative 1/2. So this is the effect when we put a number before sine x. If the number is greater than 1, it will be stretched vertically. And then if the number is less than 1, it is shrunk vertically. Okay, let's go to the domain, range, period, and amplitude of these 4 functions. So we already had a while ago the domain, range, period, and amplitude of the sine function. So we have negative infinity to negative infinity for the domain, positive infinity, I mean, negative 1 to 1 for the range, and the 2 pi for the period, and 1 for the amplitude. So here for the domain of 2 sine x, it's going to be the same. Okay, there's no restriction for x. It can be any real number. But for the range, as what you can see in the blue graph here, the maximum value is 2 and the minimum value is negative 2. So the range is now from negative 2 to positive 2. The closed interval from negative 2 to positive 2. Therefore, y can take any value from negative 2 to positive 2. And then for the period, one cycle will complete at 2 pi, from 0 to 2 pi, so that's 2 pi units. So the period is still 2 pi. And then the amplitude is the height of the graph, or that is the absolute value of the number here. Absolute value of 2 is 2. So the amplitude is 2. Okay, for the third function, y equals 3 sine x, we still have the same domain. And then the range will now be from negative 3 to 3. That's what you can see here in the green graph. The lowest value is negative 3 going up to positive 3. So the range is from negative 3 to positive 3. The period, so one complete cycle. The graph has one complete cycle every 2 pi units. So in this case, from 0 to 2 pi, that's one complete cycle, and then it will repeat again from 2 pi to 4 pi. So the period is 2 pi units. And of course, the amplitude is the absolute value of 3, so that is 3. And for y equals 1/2 sine x, the domain still the same. The range this time is just from negative 1/2 to positive 1/2. Lowest here is at negative 1/2. And highest is at positive 1/2. And then it has the same period, and the amplitude is 1/2. That's the absolute value of 1/2. Okay, let's have more examples. Okay, here we go again with the y equals sine x. So don't forget this graph. This is the graph of y equals sine x. One cycle of it, and then it will repeat, and then it will also repeat here. How about if we have a negative value here before the sine x, negative 2? Meaning to say all the values of sine x will be multiplied by negative 2. So, for example, instead of this at x equals pi over 2, the value y here is going to be 1 times negative 2. It's going to be negative 2, so it will be here. Okay, so actually the graph will be passing through here, this one. Okay, so since we multiply negative 2 to each value of y that we were able to obtain a while ago. Okay, so it will be a vertical flip along the x-axis. So there's a vertical flip. There's a vertical flip here. It's like you flip this one, and at the same time, since it's a 2 here, there's a stretch vertically. So there's a vertical stretch. It's going to be a taller graph, and then there's a flip along the x-axis. So this is the graph of y equals negative 2 sine x. How about if we have negative 3 sine x? So if we make this red graph here, y equals sine x is our reference, it will also be a vertical flip, and then it's going to be taller also. There's also a vertical stretch. Okay, so that's y equals negative 2 sine x and y equals negative 3 sine x. So if there's a negative here, what change will it create? A vertical flip. Okay, a vertical flip. And then if we have y equals negative 1/2 sine x, so it's like you flip this red graph here along the x-axis, and of course it's shrunk vertically as well. So the graph will look like this. Okay, let's go into the domain, range, period, and amplitude of these three functions. Domain for all of them, actually, it's all the set of real numbers. And then the range for this, negative 1/2 sine x. Lowest is negative 1/2, highest is positive 1/2. So that's from negative 1/2 to positive 1/2. Same period, and the amplitude is absolute value of negative 1/2, so that is 1/2. Okay, same here. The domain is the set of all real numbers. The range is, okay, from negative 2 to positive 2. Same period, and the amplitude is absolute value of negative 2, that is 2. For y equals negative 3 sine x, same domain. The range will be from negative 3 to positive 3. It has the same period, 2 pi, and the amplitude is absolute value of negative 3, which is positive 3. So that's the height of the graph, positive 3. Okay, more examples. How about if we have 2 here with the x, with the angle, so sine 2x. Okay, if you will give values for x and solve for y, and then plot the points and connect them, you will create a graph that looks like this. Okay, so you will have this. So if you have a number 2 here, actually the graph is shrunk horizontally. Yeah? It's shrunk horizontally. Okay, so from 0 to pi, there's already a complete cycle. And then it will repeat from pi to 2 pi. Okay, so that's the effect that it created if you have 2 here. How about if it's 1/2 there? What will happen? So if you will give values, the graph will look like this, the blue graph. So at 2 pi, at x equals 2 pi, we haven't completed a cycle yet. It's just half of the cycle. And then there's another half here up to here. So it will complete the cycle at 4 pi here. Okay, so it has a different period. So if you have a number here with x, it will change the period of the function y equals sine x. Okay, let's go into the details of that. For the domain, still the same. For the range, as what you can see here, it's still from -1 to 1. And for the period, it's going to be different now. Okay, so as what you can see here, the complete cycle ends at pi. So the period of this function is pi. But generally, if you have a function y equals a sine bx, where b is the number together with the angle x, then the period is just 2 pi over absolute value of b. So in this case, our b is 2. So 2 pi divided by 2 is pi. That's why the period here is pi. And you can see that on the graph here that one complete cycle is obtained after pi units. After another pi units, that's another cycle. And then for the amplitude, it's the same. Okay, it's the same. It's the absolute value of 1 here. So 1. And then for the domain of the last function, still the same. Range is still the same. But for the period, it's going to be 2 pi divided by 1/2. So 2 pi divided by 1/2 is pi times, 2 pi times 2. So you're going to have 2 pi divided by 1/2. So that is 2 pi times the reciprocal of 1/2 is 2. So that is going to be 4 pi. Okay, so one complete cycle will obtain after 4 pi units, or every 4 pi units you will have a complete cycle. So for the period of this, it's 4 pi, and the amplitude is still the same. So remember that if you have a number here before the x, the change that it will create on y equals sine x is it will change the period of the function. If the number here is greater than 1, it will create a horizontal shrink. Okay, and then if the number here is less than 1, it will create a horizontal stretch, like what happened here in the blue graph. There's a horizontal stretch if our reference is this red one, y equals sine x. And then this orange is a horizontal shrink for y equals sine x. How about if we have a +2 here? How about if our function is y equals sine x plus 2? Meaning to say, after you obtain the sine x, you add 2 to the value, or that is equal to y equals 2 plus sine x. So if that's the case, for each value of y, you will add 2 to it. So for example, this 0, y here is 0, it will become 2 because you will add 2. For here, y here is 1, so 1 plus 2, it will become 3, and so on. And you will create a graph that is like this, okay? So it's shifted 2 units upward because you're adding 2 to each value of y, okay? So you just move the graph 2 units upward, okay? Always our reference here is the y equals sine x. Okay, so this is it. And then if you have minus 3, it will make a shift downward by 3 units because it's minus 3. 0 will become negative 3. 1 here will become negative 2. 0 will become negative 3. Here it's negative 1 will become negative 4. And 0 will become negative 3 because you subtract 3. So this is the graph of y equals sine x minus 3. Okay, so what are the domain, range, and amplitude and period of these functions? For sine x plus 2, still the same domain. This time, the range will be different because you shifted 2 units upward instead of negative 1. Your lowest now will be positive 1. And instead of 1, your highest now will be positive 3. So the range of the function is the closed interval from 1 to 3. Same period, same amplitude. Okay, so if we have a plus or minus here after the sine x, the change that it will create is only on the range because there's a shift upward or downward. Same period, same amplitude. Okay, domain. Okay, for minus 3, the lowest value, okay, our reference is sine x. Lowest value is negative 1. Minus 3, it becomes negative 4. So the lowest is negative 4 and the highest is negative 2. So that's the range is the closed interval from negative 4 to negative 2. Same period, same amplitude. How about if we have on the angle inside the sine, there's a number there. If there's a minus, that's a shift to the right. So you move pi over 4 units to the right. So instead of at 0 here, you move to pi over 4. Okay? So that's a shift to the right. And then if it's plus, it's a shift to the left. Okay? So you look at this red graph and then you move pi over 2 units to the left. If it's plus to the left. So it's pi over 2 units. It's okay, this long. This is pi over 4, negative pi over 4, negative pi over 2. So the graph of this is this one. This blue one. There's a shift, horizontal shift to the left. If it's plus, to the left. If it's minus, to the right. So for the domain, same, range, same, everything is the same, okay? No change in the period, no change in the amplitude, and no change in the range. Still the same. Okay, more examples. Y equals 3 sine 2x. Okay, this time we have times 3 for the sine x, and then we have also 2 times the x. So we have 2 changes that we will create on y equals sine x. So the broken line here, or the graph here is y equals sine x. These are broken lines. And then, since there's a times 3, we will have a vertical stretch up to positive 3 and then up to negative 3 here at the bottom. And then the 2 here will create a horizontal shrink. So the graph will look like this. So there's a vertical stretch and a horizontal shrink. So the domain of the sine function is always the set of all real numbers. The range is going to be from -3 to +3, the effect of the times 3 here. And then the period is going to be pi. Okay, one complete cycle will be finished at pi. That's from 0 to pi. So every pi units. And that is created by this 2 here because the period is 2 pi over b. So 2 pi over 2 is pi. So how did we obtain pi here? This is 2 pi over 2. The formula for the period is 2 pi over the number here. So 2 pi over 2 is pi. So the amplitude is 3. Another example, we have here 2 sine x plus 1. So there's a times 2 and then there's a plus 1 here. So this times 2 will create a vertical stretch and the plus 1 will create a vertical shift upward. So it's going to be, the graph is going to, this is shifted 1 unit upward and stretched also. Okay, so domain still the same. The range will be from -1 to +3. And then the period is 2 pi over the number here. So there's no number here. So it's 1. So 2 pi over 1 is still 2 pi. Meaning to say one complete cycle will be obtained every 2 pi units. And the amplitude is 2. So the absolute value of the number here is the amplitude. So that's 2. So the graph will be like this. And then y equals sine of 1/2 x minus 2. Okay, what changes will it create on y equals sine x? So this is y equals sine x. So the -2 will be creating a shift downward. That's 2 units downward. 1, 2. Okay, or here, only at 0. Because there's also a change in the period. So the period is going to be 2 pi over 1/2. That is 4 pi. And then the range, instead of -1 to 1, it's going to be -3 here. The lowest is -3 up to -1 only because of the vertical shift created by the -2 here. And then for the period, okay, the period, the 1/2 here, you will have a complete cycle after 4 pi units. So one complete cycle is obtained only here, okay? Because that's from 0 to 4 pi, every 4 pi units. Another, we have a negative here, and then a plus pi over 4. So the negative will create a vertical flip, okay, vertical flip. So instead of this, this is y equals sine x. You will flip it and then you move to the left pi over 4 units. After you flip this, you move to the left by pi over 4 units. So this is going to be the graph. So no change in the domain, range, period, and amplitude. Okay, it's going to be the same. The range is from -1 to 1, period is 2 pi, and amplitude is 1. Okay, so that's it for the discussion of the sine function. I hope that you learned from this video. And I also prepared some practice exercises. So if you want to learn more, you better practice on the following items. And I also provided with the answers so you can check if your answers are correct. If you think you need more time, you can pause the video and answer the items. Good luck!